Today we're talking about the substitution property and also the transitive property. Here are what the properties say. Substitution property, you've actually used this a lot in Algebra 1. Anytime you would solve an equation and then substituted a value back in, you've been using the substitution property. And basically what it says is if we have equal quantities, one may replace another. So if we know that x is equal to 3, we can take x out and put 3 in its place. The transitive property is a similar property, but it's a very specific case of it. It says if two angles are congruent to the same angle, then they must be congruent to each other. And that also works for segments. So if I know specifically that angle A is congruent to angle B, and angle B is congruent to angle C, then angle A must be congruent to C. They're all equal. So we're going to look at a proof with this. And for this proof, we're given that angle x is congruent to angle y, and angle x is congruent to angle z. So we're going to set up our proof like we normally do. And we're going to start with our given information. Step 1, we're going to say angle x. Let's try that again. Here we go. Angle x is congruent to angle y, and angle x congruent to angle z, and that's given information. Now if we look at our given information, something should jump out at you, that angle x is mentioned in both of our statements, both of our given pieces of information. So if x is congruent to y and x is congruent to z, then applying the transitive property, we can say that angle y is congruent to angle z, and that's called the transitive property. Now, anytime you see me write transitive property, because it's a special case of substitution, you can also put substitution because it is technically correct. It is a substitution, but transitive is the more specific reason for this. The tip-off here was two mentions of angle x in the given, and then those other angles that weren't mentioned, or were mentioned, end up in the proof statement. That tells me it's probably transitive. Example number 2. We're told that angle 1 is congruent to angle 2, so this angle right here is congruent to this one right here, and we want to prove that angle 1 is supplementary to angle 3. Now again, you'll notice in the givens that we only have one mention of angle 1 and angle 2. We don't have any statements about congruence of two separate things. So the transitive property is not going to work in this case. So I've got to start thinking about how can I get 1 and 3 supplementary. Clearly they're not right next to each other. They don't form a straight line. So what we have to get into is how do we get 2 and 3 to be supplementary, and where do we go from there? Now I'm not going to write the given information down because I trust that you're able to do that without much difficulty. But I am going to go to the next step. So we're not going to worry about angle 1 right now. I want to focus on here, angle 2 and angle 3. In order to do this correctly, we're going to have to show that 2 and 3 are supplementary. But to do that, I need to assume something. Now, in this case, because we didn't have the diagram as the given, that's something that we often forget, is to assume that we have a straight angle when we need supplementary. So in my next step, because I have this straight angle right here, angle MAR, I'm going to say that 2 and 3 are supplementary. And the reason I'm going to say that is because, well, I just said we had a straight angle, and I have two angles together that make a straight angle, so supplementary angles make a straight angle. Now if you look at your proof statement in your step number 3, they're really, really similar. The only difference is here in the proof we have angle 2 supplementary to 3. In our proof statement it's 1 supplementary to 3. So what appears that happened is angle 2 was replaced with angle 1, and that's the idea of substitution. So we're going to replace angle 2 with angle 1, I'm going to say angle 1 is supplementary to angle 3. And a reason for this is going to be substitution. Just enough room. There we go. Substitution. So anytime I said transitive property, you could put substitution in its place, but it doesn't work in the reverse direction. If it's supposed to be substitution, it's got to be substitution. You can't put transitive here, because transitive says that you needed two pairs of congruent angles to begin with. We didn't have that. Alright, I want to cover one more, and I think we'll call it a day with the notes. So in this example, we're given that angle A is supplementary to angle D. So this angle right here is supplementary to this top angle here. I also know that angle A is congruent to angle C. So let's just kind of recap what's going on here. We've got supplementary here and supplementary here to the same angle. So what I'm trying to show is that I can take this statement, the given information, and turn it into the proof statement by just making a simple substitution. So if I have A supplementary to angle D, I can take angle A and replace it with angle C. And that's the idea of substitution. So let's get into the proof. Again, I'm not going to write the givens down. You know how to do that. You made it this far. So our givens were A supplementary to D and angle A congruent to angle C. We said that's given information. You're still going to continue to write those in proofs. Step 2 is going to say angle C is supplementary to D. So I'm just taking that proof statement and writing it right here. And I know that's true because A was replaced with C, and this statement right here in the given information allows me to do that. So I'm going to say that's substitution. And that's it. So again, substitution can always be said when it's either supposed to be substitution or transitive, but you cannot put transitive when it is supposed to be substitution.